am I doing? Combustion? Okay. With me? Eyes up here. Eyes up here, people. Let me see your faces. Okay. This one, what's the name of C3H6? Name that baby. It's got 3 carbons. What's the word for 3? No. You're thinking organic. Meth. What do you light your gas grills at home with? Methane. No, not methane. Propane. Okay, prop. 3 is prop, but there's a 2N of the hydrogens, so it's not propane, it's propene. Okay, so this is propene. This is quick review. Okay, so propene plus oxygen yields always carbon dioxide and water as our combustion reactions, yeah? So we just need to balance. I said balance C's and H's first, save your oxygens for last. How many carbons? Carbons, let's go. If you're doing your homework right now, I'm not going to review your homework. 3. Guys, participate with me. How many hydrogens? What coefficient do I need? 6, so I need a 3 here. Okay, so how many oxygens total as a product? So 3 times 2 is 6, plus that is 9. So you would say 9, but you need 9 halves over here, which is technically 4.5, right? So you need 4.5 times 2 is a 9. So you would put 4.5 there and then go, nope, can't put a decimal. I must multiply everything by 2. So then that would be 2, that would be 9, that would be 6, and that would be 6. Okay. Keep those on your desk for me right now, okay? We're going to talk about how we can expand upon solubility rules a little bit and actually why they're significant, okay? So let's do net ionic equations. All right. Biggest slide of the day. And then I'm going to do like 5 practice questions, okay? I'm going to be quiet and let you write down some stuff first. And I'm going to check that your homework is on your desk. I'm going to be quiet and let you write down some stuff first, and your homework should be on your desk. I'm swooping around like a stealthy ninja. I should see it. Josh, you understand? Understand? Right, Caroline. It's going to take you to agree to me tomorrow. It's 90. You know, it's not that bad. All right, I promise that, well, actually, I'll let you finish writing what you need to do. I know, long slide to start with, and then we're going to do some practice problems with that. And I have a problem set 10 with your name on it. Anybody wants to claim that eventually. All right, now. If you didn't get your problem set 10 back, you turned it in. Okay, I'm going to scroll back down here. I'm going to walk you through a process, okay? So I'm going to, as I go through the steps, I'm going to do an example on the board. So just make sure you write down this example with me, okay? So what we have is we have to be able to talk about really what's happening during a reaction. Like truly what two compounds or two ions are truly coming together. For example, to make a precipitate, to make a gas, to make something very, very special. Because yesterday we talked about, you know, making all aqueous solutions. But one thing we didn't mention yesterday is that you can make A, B, and X, Y go together as A, Y, X, B. And when these are made, if I go ahead and say all of these are aqueous, and neither of these things precipitate out, I'm assuming they're all aqueous, right? Aqueous, aqueous. Okay, so if I assume everything's aqueous, here's what it looks like. Picture this now, okay? You pour a liquid into a test tube. You pour another liquid into a test tube. Nothing happens. Dun, dun, dun. Okay, nothing happens. Literally no precipitate forms, no bubbles, no color change, nothing. So, are there any evidences of chemical change? No. So if there's no evidences of chemical change, you assume nothing happened. So we call that no reaction, yeah? We did that for single replacement when we were like, oh no, this metal's not active enough to replace the other metal. So we said no reaction because it's just not active enough to push the other metal out of the ionic compound. It can happen the same way, slightly different actually, in a double replacement reaction. If everything we make is aqueous, it looks like nothing happened, so we assume no reaction. So in order to actually explain that on a more higher level, we need to actually write out the net ion equation, which is literally writing ion, 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 equals yields ion, 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 ion. That's all we're writing. We're showing that literally nothing happened. The ions are still simply whatever their form was prior to the reaction occurring. So that's what a net ionic equation is. What we're doing is we're canceling spectator ions. Spectator ions. If you go to a sporting event and you watch, what are you called? Spectator. You are the audience, right? So if you're a spectator, what do? You watch. Do you participate in the game? Nay. Okay. So you don't do anything. You're just watching. You're not participating. You're not precipitating. You're not doing anything. Okay. Okay. So you're not doing anything. That's literally what the ions are doing. So we want to actually write out a written reaction for the things in solution that are reacting. So that's what we need to kind of narrow down. Okay. So net ionics. Let's do this with table as we go. We have silver. Let's do silver nitrate. Silver nitrate. Go. NO3 plus sodium chloride. Chloride? Cl. Okay. Double replace that, baby. What's happening? Ag. Cl. Hold on. Pause. What's the charge of silver? You're going to be a cheerleader again? Okay. Silver's number 1. Okay. Silver's number 1. Chlorine's got a -1 charge. So what's the rest? Because those crisscross out to 1 and 1. NaNO3. Good. You have to put your cation before your anion. And we all know nitrate's the big honking anion in here. Don't be a homewrecker. Keep it together. Okay. So now you have your solubility rules in front of you, right? First of all, is this balanced? Yeah. Silver, silver, chlorine, chlorine, nitrate, nitrate, sodium, sodium. Good. Okay. So we got BCE done. BCE, balanced chemical equation. We've got the balance. We've got it balanced. Now figure out the solubility rules. Look at nitrates first. What's the rule for nitrates? You get your solubility rules in front of you. Always soluble, okay? Always soluble means we write aqueous. So we want to put aqueous over here. Chlorides. What's the rule for chlorides? Chlorides. Always soluble except for where the exceptions. Heavy metals. Silver, lead, ACDC, mercury. Come on, people. Culture. It's a heavy metal, kind of. Okay, so this one's going to precipitate down, yeah? This is solubility. This is insoluble. These are soluble. So now we've got a reaction happening. We can see the chemical change. We can see the evidences of chemical reactions. Now, next step. So let's look at our steps here. Determine solubility for each reacting product. I didn't explain this earlier, but in my question I said solutions are aqueous, yes? Solutions of silver nitrate and sodium chloride. Okay, so everything's solution, precipitate, solution, aqueous. Ionize separate all soluble compounds. So which things are soluble? The aqueous ones or the precipitates? Aqueous are soluble. So literally what you do is you just break them back into their previous ion form. So break this guy up. What are the 2 parts? Charges 2. Give me the charges. Silver 1+, okay. Break it up. Nitrate 1-. Okay, so I'm just breaking them up and I'm saying they're added together because that's what came together. Same thing, this one's aqueous, sodium chloride is aqueous. Break it up. So plus sodium ion and, tell me, be confident. Chloride ion, thank you. Next one, silver chloride, ionized or not? No, leave it alone, people. Don't touch it. Put a box around it so you keep it in a jail cell. I don't care. Do not break it up. Next. Is this one ionized? It's aqueous, yeah? Ionize it. Ionize it. Go for it. Na, so plus sodium ion and nitrate ion. Okay. So, check.
Good morning, teachers. Please pause the interruption. Any students going on the horticulture field trip should report to the bus lot at this time. Thank you.
Nobody's going. Okay. So, step 1, done. Step 2, ionize. And we just walked through that example. Now, step 3, cancel spectator ions. Spectator ions are the ions that are just watching. They're not playing in the reaction. They're just simply whatever they were to begin with as a reactant. They're exactly the same. Like when I say exactly, I mean to the T. The for example, sodium ion. The charge and everything is exactly the same. So which of these are exactly the same from start to finish? So you see sodium ion here and sodium ion here. They're the same. I'm canceling them out. And then you said nitrate. Nitrate's the same here and here. So silver ion is locked up in the gel cell over here, the precipitate. And then the chloride ion is the same way, so we cannot cancel those. So our final answer, rewrite the final NIE, the net ionic equation, NIE, is what's still over there? Silver ion, yeah. What else? Chloride ion yields silver chloride precipitate. That's it. It's just we're simplifying the reaction down to really what's happening. Like I can put all kinds of dinosaurs, puppy dogs, and kitty cats in a test tube, and that's going to happen. But if I put this in the test tube, literally what's going to happen is the silver ion is so attracted to the chloride ion, they form a precipitate. The rest of it's just watching. That's it. We're just expanding upon our knowledge. Ready to go to the next page? Let's do some more practice. Yeah? Okay. So this is a double replacement. We're going to do single replacements as well. Ooh, this is what's happening. The salts and stuff are being pulled apart by water, or they can actually stay clumped together. It depends on their solubility. So we'll do some ion examples in a little bit. Okay, lead 2 nitrates and potassium iodide. Think about it. Get ready. Go. Lead 2 nitrate. Okay. Potassium iodide. Ki. No 2 because they're both a 1 plus and a 1 minus, right? You're thinking iodine, like simply diatomic iodine. Okay, double replace that on your paper. You should be writing down every example with me today because I'm only doing a couple for you. What's it forming as you double replace? So you're going in your head, this is the cation, this is the anion. This is the cation, this is the anion. Go for it. Where's the 2 coming from for PBI2? Lead's charged. Good job. Keep going. Name that. Potassium nitrate. Good. Yay, we're getting our nomenclature. Okay. Balanced? No. Balance it. 2 in front of the Ki? Is that what you said? Okay. Good, because we had 2 iodines to take care of, so we needed a 2 here. And then we saw, oh, we only made 2 potassium, so we had to go fix some potassiums. And we're like, oh, I wonder if 2 nitrates. Yep, we have 2 nitrates. So it all fixes itself. Okay, now, first step is done, BCE. Second step, figure out solubility rules. Who is the precipitate? Look on your solubility rules. So I'm assuming that the reactants are aqueous because I'm telling you most of the time a solution of lead 2 nitrate and a solution of potassium iodide come together. So tell me about lead 2 iodide. Why precipitate? Heavy metal and it's an iodide. If you look in the iodide category, everything is soluble except for what, and what? Silver, mercury, and lead. Okay. So precipitate, nitrates? Aqueous always, right? Like I don't even have to look at the solubility rules for nitrates anymore. They're always soluble. Okay, we know who's soluble and insoluble. The next step was to break them up. Okay, break up the soluble ones. So let's do this one quickly. Lead and nitrate. So we have lead. This one's tricky, okay? Look at where I'm pointing. There are 2 nitrates. That's what the subscript 2 means, yeah? So you literally have to write, oops, sorry, I forgot the 2 plus on lead. So lead 2 plus, because that's the charge of lead, plus 2 nitrate ions, because you literally need to describe how many of them there are. Not bad. Okay, keep going. How many K pluses? 2 of them, because there's a big coefficient of 2 in the front. So you're going to describe these as 2 for both of these ions. So there's 2 K pluses and 2 iodines. Yeah, because this 2 gets distributed. All right, so everything in the front is soluble. Next. What I wrote right here? Lock it up. Don't let it go. It's a precipitate. Do not mess with it. Keep it as is. Next. I hear you. 2K plus and 2 nitrates. I'm going to squeeze this one in over here. Okay. Okay, so these take up a little space, so leave yourself some space. All right, step 2 done. So we did solubility, we did ionization. Next, cancel. Tell me what I'm canceling. So they're gonna be exactly the same, right? So there's 2 nitrates here and 2 nitrates here. 2K pluses, 2K pluses. Anything else? Nope. Okay, rewrite. Final answer, Pb2 plus what? 2 iodides. Yields. Lead. Name it. Lead 2 iodide. I think we need to take our nomenclatures again. You guys are getting good. Okay? If you have not retaken nomenclature, please do so. Okay. Let's do one more double replacement, and then we'll do a single replacement, okay? And then you guys will do your lab. All right, magnesium chloride. Look at it. I'll give you 30 seconds to write down your reactants. All right, shout it out. Magnesium chloride, go. MgCl2, where's the 2 coming from? Magnesium charged, chlorine is a 1 plus, good. Sodium phosphate, Josh, sodium phosphate. Na3. Say again? PO4. Okay? And sodium has a 1 plus, phosphate is a 3 minus, crisscross, okay? Alrighty, go for double replacement for me. Let me just give myself a little space. I like to write in the middle of the board. Okay. So don't forget, don't be a homewrecker. Keep that phosphate together. Magnesium what? 3, parentheses, what? Phosphate, 2. Good, crisscross your 2 plus and 3 minus and crisscross down to make your 3 and 2. And then next one, just sodium chloride. No subscripts needed because they're all 1s because of 1 plus and 1 minus. Okay, balance. Tell me when. Tell me again. 3 and a 2 where? 3, 2. Oh, you're telling me in order. Thank you. Okay. So 3 for magnesium because you had 3 magnesium, so you put a 3 coefficient. Well, then that makes you have what? 6 chlorines. So what do you need over there? Okay, 6 chlorines, and then you're like, oh my gosh, now I've got 6 sodiums. Put a 2 here, and you're like, oh, I got 2 phosphates. Aha. Okay, it all works itself out if you go in order. All right, so aqueous and solubility rule stuff. Go. Tell me what you got. Phosphates? Phosphates, yeah, they're on the bottom of the sheet, right? So phosphates are insoluble. Everything is insoluble except for ammonium and alkali metal. So you're going to say, nope, not ammonium, not alkali metal. This is in group 2A, so it's definitely precipitating. This one? Fluorides? Aqueous, okay. And you're assuming the reactants I give you were 2 solutions, so we go aqueous. Thumbs up, you got me so far. Beautiful. Okay, keep going. Ionize. What's up?
The 2Na3PO4, how is that?
Alkali metal. Well, all phosphates are insoluble except for the ones that are soluble, alkali metals and ammonium. Okay. Yeah, good question. Good question. Everybody with me on solubility rules? Give me a thumbs up again. All right, I'm giving this to you. Make sure you know how to use it. It's a cheat sheet. All right, ionize. Ionize this one. How many magnesium pluses? How many 2 pluses? 3, because there's a 3 here. So you go 3 Mg, 2 plus, and then how many chlorines? 6, so plus 6 chlorides. Keep going. How many? 6 sodium ions, and then nothing. So how many phosphates? Yeah, confident people. I'm proud. Okay, so we got all of our ions, our charges, and all. All right, next one. I leave it alone. Mg3, PO4, 2 precipitate, because you don't mess with the precipitates. They stay as is. They're insoluble. Last, 6 sodium ions. I hear you. Keep going. 6 Cl minus. Yay. Okay. What am I canceling? All but what? Everything except for the magnesiums and the phosphates, because they make up the magnesium phosphate precipitate. Good. So you're starting to see the trend. It's just the stuff that's precipitating. Those are the ions that are playing in the game. Everybody else is a spectator. So chloride and sodium, they go away. The only things left, 3 Mg, 2 plus 2 phosphates yield magnesium phosphate precipitate. Not so bad, right? I knew you were scared going into this. Let's do one single replacement. I'm going to use one off of your homework. So some of us didn't do single replacement for our homework. Nope, wrong thing. Thank you. Zinc is mixed with lead-2 nitrate. Zinc is mixed with lead-2 nitrate. Write it down. Zinc is mixed with lead-2 nitrate. Zinc is mixed with, tell me the formula. PbNO3,2. This is the first one on the single replacement part of the reaction prediction homework. All right, zinc, solid, liquid, gas, what? What do you assume? Solid. It's a metal, right? Solids are metals are room temperature. Metals are solids at room temperature. This one said a solution of, so we're assuming what? Aqueous, okay. Pure liquids is where you put an L. Most things are not pure liquids. Most things are solutions of something mixed with water. Okay, does this thing replacement occur? You have your activities series in front of you. I can just scroll back. I'll show you activity series. I have little copies that I'll leave on the desk. I just didn't make you guys copies for personal use yet. Activity series, right here. Okay. What are we looking for? Zinc replacing lead. All right. Is zinc more active than lead? Yay or nay? Yay. Zinc, lead. Zinc is up. It's like super active. It's going to boot out lead out of that relationship. Speedy up here. Hold on. Almost back. Okay. So it's going to boot this one out. So they're essentially just trading places. Yeah. Tell me the new compounds. Pb all by its lonesome and zinc nitrate. How do you tell me the charge of zinc? 2. It's always a 2. So you put 2 subscript out here. Okay. So assuming lead is a solid, it's going to be. It's a metal. It's going to be solid. So now we got some problems here. We have solid on the product on the reactant side, aqueous yields solid, and tell me nitrate soluble or insoluble? Soluble, aqueous. Okay, so just like your NIEs you did earlier with double replacement, we have to go through and label the solubility. Done. Solid, aqueous, solid, aqueous. Second, we need to ionize things that are ionizable. Is zinc ionizable? Is it an ionic compound? No. Leave it alone. Do not touch it. Write it exactly as is. Zinc solid. Plus nitrates. This nitrate in particular, all nitrates are soluble, yes? I don't care if it's heavy metal, dinosaurs, puppy dogs, it's going to be soluble. All right, so this one, we break up. So tell me what it is. Pb what? 2 plus and 2 nitrates. Good job. Yields. Do I touch this? Is it ionizable? Is it an ionic compound? No. It doesn't look like anything we've ionized before. Leave it as is, and please write solid next to that because it'll be a clear indicator like, hey, I can't cancel this out. Okay, and what? Ionizable, yeah? Keep going. Zinc 2 plus and 2 nitrates. Okay. Remember, the rule of thumb was it had to be exactly the same. What is exactly the same from reactant side to product side? 2 NO3 minuses, 2 NO3 minuses. Anything else exactly the same? No. I knew it looked similar. Zinc solid, zinc ion. 2 different ball games, people. Can't cancel it. That's all you can cancel. Yeah. Because zinc solid is going to be like a solid mass, you can pick it up. Zinc ion is in solution, and it's aqueous, and you can't see it. It's clear. So they're literally 2 totally different things. This one has lost 2 electrons. So It's like, you know, if you were a kid and then an adult or identical twins. Not the same people, actually. Yeah. Because well, I'm going to start with this one. Zinc solid is zinc solid. It's not zinc ion, it's zinc solid. It's just a metal. Different, because it's still got its normal electron configuration. Same thing over here. We did the double replacement reaction. So when you boot out lead by itself, lead kind of takes its electrons back, and it lets zinc do the doing. So when they trade places, lead takes its electrons to make it back in its original form, lead solid, and zinc goes in the compound form to make that ionic bond. So they literally trade places and states. Okay, so new final answer. Zinc solid, lead 2, and I'm going to put aqueous down here for kicks and giggles so you guys know. Okay, and yields lead solid and zinc 2 aqueous. So these look a little different than doubles, right? You got a lot of solids involved. So if you label your solids, you're hunky-dory, you'll never mess up. Okay? Are we have an hour? I'm going to tell you what you lab. Tell me when you're ready. Just making sure that I have to flip off this slide. Yeah. What's up? Because we said aqueous to begin with, so anything that's aqueous stays aqueous. Yeah. Okay, so your lab requires you to experiment with chemical reactions. All closed-toe shoes, I hope so. I didn't bring my grammar sheet with me today, so I'm going to be back in the lab minimally with you. So you are doing 4 types of chemical reactions. The only one you're not doing is combustion. Okay, your lab sheet, listen, your lab sheet's in the lab notebook. So after that, after you finish your lab, you guys can start finishing up the NIEs on the problem set 11. That's like the very last touch that you have to do there. And I'll show you where this is on my website. But what does the lab look like, you ask? Looks like this. So you're going to be looking through you're going to be performing chemical reactions, and based on evidences of chemical changes from part A, B, C, and D, you're going to be recording your results. So what does it look like before? What does it look like after? Type of reaction and the actual reaction. So try to do that as you go through, because you're going to forget what your observations were unless you take pictures, which I'm cool. I'll be taking pictures because this is the most fun lab ever. Okay, so I have your lab groups, but we're missing some people. So let's go 3 to a station. You need paper, you need goggles. Go. 3 to a station. Goggles, notebooks.